Atom originated from the word atomos, which means indivisible. In 1808, John Dalton introduced a theory of the structure of atom. According to Dalton's atomic theory, an atom is the smallest particle that cannot be further divided. However, the development of science has succeeded in finding particles that are even smaller called protons, electron, and neutron. Structure of atom. Recall the three subatomic particles in the structure of an atom that you have learned in Form 1 as shown in Figure 8.7. When the number of protons in an atom is the same as number of electrons, the atom is neutral. I think we have learned this already. Okay, we see how many electrons we have here. 1, 2, 3. Okay, 3 electron, which is negatively charged. And the number of proton is 1, 2, 3. So we have 3 proton also. So the number are equal. That's why they are neutral in terms of charge. And we also have neutron. And the neutron itself is neutral. So this atom is neutral. Okay, now formation of positive ions and negative ions. When an atom loses or gains a neutron, the atom becomes a charged particle known as ion. Positive ion. Now we look at positive ions. An atom that loses electrons from positive ion, cation. Okay, example. Look here. Initially, we have, for a sodium atom, we have 12 neutrons. As I mentioned here just now, that neutron is neutral, so it has no charge. Charge is 0. Now, sodium also has 11 proton, so we have positive 11 charge, and electron is also 11, and the charge is negative 11. So, the charge is 0. Okay, 11, positive 11 plus negative 11, total is 0. But what happens if it loses one electron? Okay, when it loses one electron, now you can see initially it has 11 electron, now it becomes 10. You can see it becomes 10 electron. So the charge for electron is only negative 10. Okay, so 11 minus 10, we have 1 positive. So in this case, the charge of sodium is 1 positive. Okay, what about negative ion or anion? Negative ion gain, an atom that gains electron. It gains electron, forms a negative ion. Okay, you can see this is neutral, right? This is chlorine atom. It is neutral. So what happens? It gains one electron. In this case, it gains. So as you can see here, we have 18 electron, and it becomes negative 18. The charge is negative 18. So the total charge is negative 1. So in this case, it is negative ion or anion. Okay. The next thing is ionizing radiation and non-ionizing radiation. Ionizing radiation and non-ionizing radiation. When a radiation such as radioactive radiation passes through air and produces positive and negative ion, it is known as ionizing radiation. This is particle, alpha particle. Alpha particle, you can read here, passes through air. Passes through air and produces positive and negative ion. You can see here, this is negative ion. Negative ion is actually electron. And then we have positive ion. Okay, and the positive ion and negative ion split. That's why we have ionized air. Okay, this is, we call it ionization, or ionizing radiation. The next thing is non-ionizing. Okay, this one is ionizing, and this one is non-ionizing. Example of ionizing radiation and non-ionizing radiation are shown in figure 8.9. Okay, what are example of non-ionizing? The example are radio wave, infrared, microwave, and visible light. Actually, you can find this type of wave in electromagnetic spectrum. Visible light is a type of radiation also, but it does not produce ionization. It goes the same for microwave, infrared, and radio wave. Because we have all this kind of radiation around us, but we cannot see, except visible light. We can see visible light, but visible light does not ionize the air. What about ionizing radiation? Okay, ultraviolet, X-ray, and gamma ray are example of ionizing radiation. You can see here X-ray. That is why when you go to the hospital, when you need to go through X-ray process, so your relative or parents need to stay out of that X-ray room, because it is actually not safe if the dose is too high. Okay, for those who don't need X-ray, they should stay away from the room. Okay. Okay, I think we should